Okay, we got something that popped up into my YouTube feed, and I thought this was pretty cool. All right, we got the ultimate FPS controller design and build. Look at this thing popping off almost 1 million views. This is intriguing.
Hey, Charlie Pyatt here. This episode I'm making a custom controller specially designed for first-person shooter games. I've been into making custom controllers and input devices for computers since I was a kid, so I'm really looking forward to digging into this project.
Nice.
The main goal of this build is going to be to combine a trackball with a gamepad to get the benefits of mouse aiming with the compact form factor of a console controller.
Nice.
The mouse keyboard versus gamepad control debate has been around for decades.
Oh, yes.
I think it's commonly
It has been here for far too long, my friend.
agreed at this point that mouse aiming offers a competitive advantage over aiming with an analog stick in first-person shooters.
Yep. And plus, there's the ever looming, if you have a controller and your game has crossplay and an esports scene, the controller's probably going to have some level of aim assist.
Talked about less is why this is the case. I have an example here of using both a mouse and gamepad analog stick to move a cursor on a computer desktop. When you move the mouse, the cursor moves proportional distance on the screen. Moving the same cursor with an analog stick is
But look how smooth this arrow moves from folder to folder. So, if you're going to apply it to like a video game, when you can smooth out the movements that are happening in front of you, it's easier to react quickly when things are moving more smoothly. But if you look at this arrow over here, yes, it is getting to its destination quicker. But in a video game, if something were to happen mid-flight of this arrow moving, it's going to be hard to see it because it's not moving smoothly. It's very like explosive in terms of like speed.
Is more difficult. You have to anticipate cursor acceleration and deceleration as you move the stick in the direction you're trying to move the cursor. It's way easier to over or undershoot a target, and it takes more practice and concentration to get right.
Yeah.
In reality, FPS games are pointing games.
I like this little filter he's got on. Track cursor and warp footage. Oh wait, is this his controller? This thing is schmoving.
Computer desktop, you're moving the pointer around a fixed screen. In FPS games, you move the desktop around a fixed cursor. It's hidden behind the graphic implementation of the game.
And you fuck with the FOV to make it look like rounded and shit.
But at the highest levels, FPSs are mechanically the same as clicking an icon on a computer desktop when it comes to aiming and shooting.
Oh yeah, Jumbo
While
Tile
mouse
Frenzy.
may offer better aiming, it's really unable to handle sustained movement. To get around this, FPS games on the PC use the keyboard for movement, but that isn't a perfect answer either. Movement with a keyboard is limited to only 8 possible directions using combinations of the AWS and D keys.
Yeah.
Beyond this, PC games...
I mean, if you hold WA, you obviously go like diagonal. If you hold like S and D, you go diagonal down. So you have 4 single key ways, and then if you want to do like 2 keys, you have 8 ways to move.
Have to add in movement modals to get the control fidelity needed in most games. Holding shift to run or control to sneak are examples of this. Gamepads, on the other hand, don't suffer from any of these movement limitations.
No.
You just push the stick in the direction you want to go. The further you push the stick, the faster you go in that direction. With a simple analog stick input, you can get much higher precision movement and speed controls in a much more intuitive package.
Oh yeah.
So this is why I wanted to explore making a controller that combines the best aspects of a mouse and a gamepad.
Look at this movement on a gamepad. So this is like your standard like Xbox. 2 joysticks, D-pad, buttons, thumbs, triggers, and then aiming trackball. This is the ball, and you just leave your hand right there, and you just click. That is, I know trackball is like an older thing, like 1990s and whatnot. I do know like if you go to like a Best Buy or like a not a Staples, like an Office Depot, you might find a mouse like this. This is like very office. So this is just cool. trying to
by
combine them.
combining a trackball for aiming and an analog stick for movement together in a single controller. The concept of combining a trackball with an analog stick isn't a new idea. Valve explored a bunch of these concepts back in...
Oh, dang, really? Look at all these. I am just so ignorant. What the fuck is this? Is this like a football that's like painted white? Or is this like the front and the back? What is this? This is obviously like a back thing. Like, look at, like, what is this? What is this? Holy crap. Like, what is this? Oh, those are the boards. And then, you know, as time goes on, we kind of like, oh, and then these are the, what do you call it? The finger sensors, the thumb sensors. All right, this is cool.
In 2013, when they were developing their Steam controller. There's a really interesting promo shot that shows the prototype development process and how many design concepts were explored. In the end, you can see they went with dual touchpads for inputs over the trackball concepts. Going back even further, I found this research paper from 2010 that explores a similar concept of combining a traditional gamepad with a trackball as well. So I guess my question is, why isn't this a thing? If integrating a trackball into a gamepad is such a great control scheme, then why doesn't this product exist?
Oh.
I'm honestly not sure, and that's what I want to find out by building this concept for myself.
Why doesn't it? I mean, well, it has existed back in the day. I mean, you just showed a product there, so why it doesn't exist now? I don't know why it doesn't exist now. This is like a fantastic another input method for people to just like get exposed to. I think this is a great idea. This is fantastic.
First step on this project is going to be figuring out what the exact inputs and buttons are going to be on this new controller design. I already know I want to maintain the functionality of a normal gamepad, so I'm going to keep pretty much everything intact as far as inputs go there. The big change is that I'm going to be removing the right analog stick because that functionality is going to be replaced by my new trackball. For the mouse inputs, I want to maintain the left and right mouse buttons, but will be removing any additional function buttons or switches.
Nice.
I did want to keep the scroll wheel in this design, though.
Oh, wow, really? Scroll wheel on a controller. Huh. What would that look like? I mean, I got a controller like right here. Little whatever. Like a whatever controller I used to play like Monster Hunter. So, what is this? Got this like right here. So, immediately I try to fit like a tracking ball. I mean, because I don't have the product in front of me. If I were to think about the setup, I mean, I don't know. It feels like it's got wheels. I feel like he could take this product somewhere.
Navigating large linear menus is just so much easier with a simple mouse wheel, and something I always miss on console games. When I move all the elements onto the new controller, everything is roughly fitting into space. So now that I know the physical inputs I want, I need to dial in where they're going to be more precisely on a practical controller layout. For this phase of the design process, I'm going to model in some placeholder input objects in Fusion 360 and 3D print them out.
Whoa!
I just pulled the rough dimensions for these off an Xbox controller and mouse I had using calipers to roughen the shapes I need. The next step is to take the physical buttons I printed out and put them into clay, which I can physically model into the controller shape I want. For sculpting, I'm basically just working the 3D printed buttons and components into a position that feels comfortable. As I worked on the shape, I realized I really wanted to have access to both the front and rear of the trackball. The idea being that I could move the trackball with either my thumb from the top or ring finger from the rear while holding the controller.
That's
this
cool.
will let me do some fun moves with the controller once it's all built.
Oh, you see it right? I don't want to. Okay, let's just keep going.
I could operate the ABXY buttons at the same time I'm moving the trackball, do micro adjustments with both fingers to get better aim, or drag my ring finger on the back of the trackball to change the resistance of the motion. These are all interesting options I really haven't seen done before, so I'm going to be incorporating them into the design for sure. With that concept in place, I just had to keep working the clay around until I got it into a comfortable position for my hands and all the inputs. After some more work, I was pretty happy with the way it
This
was
is so
feeling.
cool.
I didn't bother cleaning up the surface or doing any advanced detailing in the
Yeah.
clay. This model was really about feeling right, with
Yeah.
the surface looks not really mattering at the moment.
No, it's more functional than it is attractive looking. All right. The thing with gamers, they don't care how like at least like the professional players, they don't care about how their input looks. They just need the best one with the most functionality, is what I would say. I mean, shit. Yeah, I mean, you could take like a whatever, like Xbox controller. I mean, you got like some of these where like all the buttons are like mouse clicks. Essentially, there's no mushiness to any of the buttons. There's like tension options that you can put in the joysticks. There's like paddles underneath and whatnot. I mean, the limitedness is it's limitless with what you can do with this.
With my clay model done, I started prepping it for scanning. For this project, I did 2 sets of scans. One with the controller oriented vertically on the turntable, and a second set of scans with the controller laying flat. I deleted the turntable from the scan data and then merged the point clouds together to
Claw bros are seething right now.
generate my final mesh. The end results came out really nice, and this has more than enough resolution and detail for what I need out of this scan mesh. With my clay model scanned in, the bulk of the remaining digital work on this project is going to be creating a working CAD model of my controller for 3D printing. The steps in this project are to take in a scan mesh from my clay model, clean it up, convert it into surface geometry, and then make a precision engineered enclosure that will hold all my real-world physical components. For this project, I'm going to be using Rhino 3D for my mesh cleanup and surfacing.
Okay.
For the final product engineering, I will need a parametric 3D modeler that is better suited for dimensioning parts and managing components. For those parametric steps, I'll be using Fusion 360. So with my digital tool chain figured out, I'm going to start with my scan mesh pulled up in Rhino, and I'm going to do a bunch of operations to clean it up so I can start doing my surface creation over it.
This is so cool.
First thing I'm going to do is import the CAD models of the buttons I 3D printed and place them in their positions on the scan in Rhino.
What is also really cool about this video so far, this literally just shows you like the process of making like a physical product. This is cool.
These will act as references for building the rest of the model in later steps. For the scan cleanup, I'm going to be using Grasshopper, which is a graphic programming language for Rhino. From here, I can bring in the buttons I placed in 3D space and subtract those from my scan to get just the body of the controller. After that, I run some smoothing operations using a voxel plugin called Dendro and convert the output to surfaces. This takes me from a pretty ugly scan mesh, which I have no easy way of editing, into a nice clean surface model for working on. Next up, I'm going to use the clean scan data to generate a network.
Bro, this thing looks like the Hunchback of Notre Dame in terms of controllers.
Of NURB surface patches that will define the outer shell of the controller. Defining these NURB surfaces is commonly called surface sculpting or Class A surfacing, and is a whole subdiscipline inside the 3D modeling for manufacturing world. At this point, I've worked over the surface patches and have a network I'm pretty...
Bro, if this thing takes off, Battle Beaver is shaking in their boots right now. Like, oh my god. Well, who knows? I'm just like memeing right now. But honestly, just as like a whatever, if all these buttons, if you turn them all into like mouse clicks instead of having like a mushy travel distance, that will immediately make this entire controller feel better.
Pretty happy with. If I turn on the zebra stripe view, I can see some minor warps happening, but I don't see any major jagged discontinuities going on or anything like that. Likewise, with the environmental map turned on, the reflections all look clean enough for what I'm going for. In the end, I'm going to be 3D printing, priming, and sanding all these parts, so I don't quite need to be as obsessive as I would if these were going into production tooling. And with that done, I'm pretty much wrapped with my Rhino work. From here, I can export all this as 3D step files that I'll later import into Fusion 360. Before I move on to the parametric CAD phase, I need to figure out how all the electronics in this are actually going to work. I want this to be a wired controller, so I don't have to package the battery in the device itself. Beyond that, I know I want this to be recognized as a standard Xbox controller and USB mouse on my PC.
I wonder why he went with the Xbox controller. Is it just universally agreed upon like all gamers that the Xbox one just feels like better to hold as opposed to like a PlayStation one? I wonder if that's the case.
I want to stick to repurposing off-the-shelf components for all the electronics as much as possible. With all that in mind, I'm going to order a third-party Xbox controller and trackball to continue my testing. I've got my controller and trackball in, but before I tear these down, I want to actually...
Is this Aim Lab or just Valorant, like aim trainer thing?
Use them together and make sure everything works. I'm going to be using the AimLab's FPS trainer for all the testing going forward, so I need to verify this control scheme is supported before moving on. I'm using my Xbox controller for movement and trackball for aiming here in AimLabs, and everything seems to be functioning okay. Now that I know my hardware will work for what I need, I can tear the trackball and gamepad down and start figuring out how to integrate their internals into my new controller form factor.
That's cool.
Starting off with the trackball, the internals are...
That's gotta be like a whole new thing of like muscle memory to try to get under your belt. Oh my god.
Looking straightforward and pretty good for what I'm trying to do. The main button and controller PCB is a little larger than I'd like, but the scroll wheel and trackball sensor are separated off the main board, which is really good. The scroll wheel is basically just a potentiometer connected by 3 wires. I can extend those wires to position the scroll wheel anywhere I want in my controller relative to the larger board. The optical sensor for the trackball is on its own mini board, which is also great. This is hooked up by a standard 6-pin FlexPrint connector. I can just order some longer links of this standard ribbon and, like the scroll wheel, position the sensor however far away from the main board as I need. So all in all, the trackball internals are looking good. So with that, it's time to move on to the Xbox controller. Unfortunately, this isn't looking as promising as the trackball.
Oh boy.
The PCB on this is very large and won't even come close to fitting inside my controller design.
Oh man.
Half my controller space is also taken up by the actual trackball, so I can't have electronics that are anywhere near this size.
Oh yeah.
I could try ordering additional controllers to see if they have smaller boards, but I'm pretty sure they would all be in a similar layout and form factor to what I have here. My options on this one are pretty limited. The strategy I'm coming up with...
Okay. So immediately, one concern is that I don't know how heavy the trackball is, and I know we're just in like not even like the beta of like V1 of this thing, but I don't know if a heavier trackball would be good or a lighter trackball would be good, because if you look at like M&K, just gamers. The trend has been, going towards a lighter and lighter mouse to have a smoother and less, essentially just to have like less friction on the mouse pad, essentially. You have static friction, which is the friction, or maybe not static, but like initial friction, which is the friction that it takes to move your mouse from a dead stop to start moving. And then you have dynamic friction, which is when your mouse is moving to change its direction. So usually a lighter mouse will let you have a lower, initial friction and a lower dynamic friction. So that is one concern. And also like literally just make all the buttons mouse clicks instead of having like a long travel time.
With to get around this is to move the Xbox controller board to a breakout box and connect all the electronic components in my controller through a single multi-conductor cable. This will basically work like a bunch of extension wires coming off each contact on the Xbox controller board and going to a button in my custom controller. Once everything is done, I should have a single cable running between my controller and breakout box, and then a single USB cable that connects to the PC. When I plug the USB into my PC, I should see 2 devices, Xbox controller and the trackball. It all sounds good on paper, so I think I'm good to continue on through my design process. It's a good time to put in some work on the industrial design of the product and establish the overall look and feel of the controller. I can see the controller as being pretty standard on the left side, with the right side being pretty weird. I really want to ramp up the crazy on that right side, so I'm going to cantilever those side shoulder buttons off the controller as extended arms. I also want an independent element containing the trackball. This will help visually separate it from the surfacing seen on the rest of the gamepad.
Right.
As I did more sketching, I came up with a basic design theme where high contrast parts were holding in all the interaction elements.
Yeah.
With an overall picture of the form I want to explore, I can move into Fusion 360 for my parametric CAD work. For this section, I'm going to be stepping through my parametric timeline in Fusion 360 to show my build process. I've got my surface design pulled in from Rhino. The buttons and trackball aren't integrated into the form at this point. My first step is to cut away a space for the trackball itself. Next, I blocked in the lower area that will house the trackball sensor. In the section view, I've added an internal bracket to hold the sensor.
Okay.
With that all roughed in, I'm going to move over to the trackball cradle. This is the actual element that will hold the trackball in place. Basically serves to isolate the trackball a specific distance from the optical sensor in the controller body.
Instead of a fidget spinner, it's just a fidget ball that you can just like flick and it just infinitely goes.
The plan from here is to have adjustable pins that go in and hold the trackball in that cradle. These pins are going to be set screws tipped with ceramic bearings and should allow me to make micro adjustments to the position and resistance of the trackball once it's all installed. So yeah, you can see the trackball holder isolated into its own separate body now. So now I'm moving on to the design and placement of the A, B, X, and Y buttons. These will each work as their own sub-assemblies. In this design, I can load my tactile switches into this housing, then push the outer button down to seat it. They'll slide down onto this larger body that will be part of the outside of the controller.
Okay.
That'll prevent these clips from bending back out, essentially capturing this button in place. That's the kind of problem solving and design you have to do on each of these components. Each part of the controller is its own little design and engineering challenge that you have to figure out and integrate back into the larger product. As I'm installing all my buttons, I'm constantly checking them against my original source model from Rhino. This is really important because it lets me see the difference between my digital model button placements here in Fusion and my real-world clay model button positions. Next up, I'm going to be building out the buttons on the left side of the controller. I'm modeling in my left shoulder and trigger buttons here. The trigger is going to be pretty...
I love that he just has the scroll wheel here, just because, fuck it, why not? We took the trackball off the mouse, let's take the scroll wheel too. That is so cool.
Unique. I kind of want it to swing down under the body of the controller.
If you want to add like another level to this, have like an infinite scroll wheel, or have like a button somewhere else, like maybe like on this side, to where you can either lock the scroll wheel in place, well, not lock it, but like have it like be steps, or you hit the button and it just infinitely scrolls. Oh man.
Kind of cutting and sculpting it until I have a shape that looks good. With those buttons roughed in, I'm moving on to the top surface of the controller. I have my directional pad installed now. I really wanted to add these kind of tabs on the end of the directional pad. I like the idea of being able to swap those out for longer or shorter ones depending on the performance characteristics you wanted out of the controller. Okay, so now we're moving on to the analog stick install. I've modeled that component out and built in a little bracket on the inside of that controller body. Also modeled out the actual analog stick hat for the outside of the controller. Up next, I'm going to get into those cantilever buttons on the right side of the controller. Inside each of the arms is a little recoil spring that will add resistance to the button pull. When you depress the button on the outside, the lever arm pivots around a center pin, and then this little internal hammer comes down on one of those mouse switches held in a bracket.
Right.
So the way most controllers work is the buttons and switches.
I don't know if having... Oh wait. You can't have paddles on your right hand because you can your right hand is messing with the trackball the entire time. Could you have paddles like on the bottom of this in order to make it so that your right hand is only worried about the trackball? Because I mean, you got like how are you holding this thing? Are you using like your thumb and like your ring to control the trackball? Like, bro, my ring finger dexterity is dog shit. So me trying to be like any sort of precise with my ring finger is just gonna spell like bad news bears. But maybe if I did like a thumb and like a middle finger type of deal, that could be more precise, which would only leave my pointer to mess with those three paddles like right here. So I don't know. Would having like some more paddles like on this side, like on the other side, be like too much of an ask? I don't know. I'm just like throwing shit at the wall.
Are spread pretty evenly throughout the controller body. By having all my right shoulder buttons on cantilevered arms, I'm pushing all my switches to the left side of the controller. I'm
Mm-hmm.
basically forcing all of my electronics components into this little tiny area over here. This is where product designers and product engineers butt heads a lot of times.
Oh yeah.
I still have to get
Everything is just mushed on one side essentially.
my left shoulder and trigger button hooked up and running. Starting off with my left shoulder button, I'm shelling and drawing in a post that this button will pivot around. On the inside section view, you can see how this will clip into place on the main controller body. I should be able to just press this one in from the outside of the controller during assembly and it will snap right into place. Now that I have the left shoulder button installed, I need to do the left trigger. I can put the trigger on, then slide 2mm rod stock to lock it down.
Mm-hmm.
There's going to be a recoil spring that I actually pulled off my donor Xbox controller that goes in here. I still haven't hooked up the hardware for the left and right triggers yet. For that, I'm adding a cantilevered arm coming off the trigger.
Right.
This assembly will twist a potentiometer that acts as an analog input for the trigger action. The potentiometer will press fit into this little internal bracket here. The right trigger arm will do a similar action and rotate another potentiometer. Moving on to the cable entry on the controller. My cable is actually going to be mounted on my trackball assembly.
Bro, it's like literally one side of the controller looks like a seemingly normal controller. But then the other side, it's just like a Picasso, essentially.
Just going to add a screw-on clamp to secure the cable as it passes into the controller. So yeah, this is kind of the home stretch here. The last step is to make a connection method for all these separate outside parts. The outside shell is just kind of floating in 3D space right now. It needs to be linked together somehow.
Mm-hmm.
This kind of all comes together like a complicated puzzle box. The parts need to be assembled in a specific sequence. Once they're all in place, they should keep each other locked together. So yeah, with that, we're all done. If I kick on my old reference model, you can see everything is pretty close to where it was in the clay model.
Nice.
The important thing is that whenever I had to make a button placement change due to mechanics, I was able to check it against the physical clay model button position. This would let me know if that change would impact the ergonomics of the final design. With my CAD work done, it's time for 3D printing. For that, I'm going to export my objects as step files to Preform. Preform's the slicing program for my Form 3 SLA resin printer. I had to do these in several print batches, but the parts came out looking really good. Each of the print batches goes through an IPA bath and then a final UV cure. With all those done, I have the bulk of my final printing run complete. I need to dry fit and test the entire controller to make sure it actually works before final painting and finishing.
Xbox controller internals.
So for that, I'll need to do my wiring. If you remember back to my wiring strategy, I'm really just running extension lines off the Xbox PCB through a 24 conductor cable to the switches in my custom controller. I mapped out all the connection points I need on the Xbox PCB. These will run through a smaller terminal board that I can plug my DuPont connectors into.
Okay.
With all my wiring done and checked, I can move on to my dry fit assembly and testing. Alright, so you can see I've got my controller all dry fit together here. All the buttons are hooked up to the main wire harness and everything should be running. It's pretty awesome, finally seeing this come together.
That is so cool.
Got this hooked up to a control tester and you can see all the buttons running. So got A, B, X, Y, up, down, left, right. Analog stick.
Oh, yep, there it is.
Upper shoulders. Yeah, everything's going. The action on this really feels awesome. Like, I love these sort of extended controller arms here. It uses clicky switch from a mouse, which is way more satisfying than the membrane dome switches you find on a controller.
Oh, he did, okay.
Mouse wheel is running. That's awesome. So yeah, I basically have all the functionality of a mouse and a gamepad packed into one weird, super strange controller, which is exactly what I was trying to do.
Bro, that is so cool.
That's great. Oh, and I still have my old stick over here that works too. Nice. Yeah, this is amazing. Sort of baffled that this worked on the first try. Did some diagnostics and testing before, but really, yeah, all the boards, all the cabling, everything's worked. As long as I can figure out a way to cram all this in the enclosure, I should be good to go. But yeah, that's my one concern now is I have the DuPont connectors there have taken up more space than expected, so we're gonna see it's gonna be very tight in there, but I'm pretty sure this will all come together okay in the end. Yeah, again, I just love these switches. They're just like the most satisfying thing ever. Really liking the trackball access on the back. This is just so radically weird to be able to move the trackball and then also control it from the other side.
Oh, so he's using his ring finger to do it.
Spin really fast and make these massive adjustments and then make fine-tuned micro adjustments by sort of pinching it and just get this really nice control.
Bro, this is so cool.
It's really cool too because I can access the buttons and still be aiming around, which is super unique. So yeah, you can see right here, I'm still operating the mouse and yeah, also hitting buttons, which you can't do with a normal controller. The pin system I designed that allows me to adjust the strength of the resistance of the trackball is working fantastically.
Oh, okay.
I can just do little quarter turns.
So he even thought ahead and was like, okay, the friction of the ball is going to be a variable. So there's like these little tighteners around it, it seems, so you can adjust the tightness.
Turns on these screws to really tighten or loosen the resistance of the trackball and just get it feeling exactly the way I want.
That is so cool.
I love the stage. It goes from just being something abstract on the computer to being in your hands. It's always a little scary. You don't really know how it's going to come together or work out, but man, this is amazing.
Bro, imagine doing like 90-degree flicks or like 180s on this thing. You just like flick your thumb. Oh wait, I don't even know if you could. It would probably depend on like your sensitivity, essentially. Like the game would have to support like, I don't know, like, I mean, because if this is your movement stick, and oh my god, because like you think about using this controller in like modern games with like, you know, Halo, Apex, Fortnite, in all these games, like to do like a 180, you'd have to like, I mean, depending on your sensitivity, like either flick the ball to like the other side or I don't know, or just like move it a little bit and then reset your thumb.
Can't wait to move on. Next step is going to be to tear this back apart, paint, and then do a final reassembly. So we'll go from there. I have my parts broken back down for the painting and finishing step. I ended up using some rattle can finishing paints for both my priming and color coats on these. The detail level on these 3D printed parts is great, but it still requires priming layers and wet sanding before final painting. There are lots of parts that need to be finished here, but fortunately only the larger exterior pieces really need multiple priming passes. To build up my primer and sand it back down, I'm starting to get a really pristine surface on these final parts.
Oh dang.
For final finish, I'm going to leave the bulk of the parts as raw primer with a glossy clear coat. The small bright blue components will get a matte clear. I like using different clear coats on different subcomponents. It adds a nice texture variance to the finished design and makes it look like a more complete product.
Yeah.
At this point, I'm really happy with the way the final parts are looking, so it's time for the reassembly of everything. My final assembly steps go in almost the same sequence as the CAD build.
Okay.
I'm getting my trackball loaded into the cradle and making sure the action is working okay. Next up, I'm loading my dome switches into my ABXY buttons. Left tolerances to account for the paint buildup, but some of these need a light sanding to get them feeling right.
Okay.
I also added a very small amount of lithium grease on all my moving parts to get a smooth action on everything.
Of course he would have some lube in this. He is a keyboard aficionado, because like when I got like my new keyboard or whatever, I didn't like really understand that you're supposed to like lube the switches with like a little bit of a, I don't know, keyboard lube or whatever for like the smooth feel, because I mean, honestly, I don't notice it, but like this is something that a keyboard bro would know about, like lubing buttons. And kudos to him.
From there, I'm moving on to the left side of the controller. It's really nice having the two sides as separate parts. Makes loading in all the components and switches so much easier.
Nice. Look at that scroll wheel,
All my
dude.
left side components feel great, so now I need to load in the extension arms for the right shoulder buttons. With those in place, I hook up the potentiometer
Bro, it looks like fingers are coming out of the controller.
for the right trigger and add in the button ends
Oh, and you can hear the clicks on the arms.
for those arms. Everything is feeling spot on, and I can really see the controller coming together. I'm plugging in all the DuPont connectors into my terminals, double checking to make sure all the plugs are going into the right pins. Next up, I'm securing the main cable into the controller to make sure there is no tension put on those inner wires.
Mm-hmm.
I'm piecing all the main parts together now. With the final little push, the two halves of the controller seat together, and it's all done.
Oh,
The final little bit is to mount everything into my breakout project box.
the project box.
And with that, the build is done. It's been pretty amazing
Dang.
taking this all the way from concept to finished design.
That
It
is
took
so
a lot
cool.
of unexpected turns, but seeing it all done and together is just so satisfying.
Look at this. And this is just like version 1 of the thing. Like, if enough people see this and like what they see and want to like reiterate and improve it, bro, this guy's gonna have like the easiest time on like setting up a business and like just like making improvements on this and just massively selling them. Yeah, dude, this looks so good. But like honestly, as weird as it looks, I would say this is like the jitterbug of controllers. Remember like the jitterbug cell phone? This thing looks huge.
And with that, it's time for the fun stuff, going on to playtesting. I'm going to be running my testing 3 separate times. Once with a normal gamepad, once with a mouse, and then with my custom controller. For each of these different control methods, I'm running 3 different scenarios in aim labs. Cluster aiming at targets close together, dynamic aiming at a moving target, and then spread aiming at dispersed targets. I started with spread target testing.
Oh, look at this dude using like aim lab and shit. This guy knows his shit.
To kick things off. To be honest, I was really struggling with the new controller at first.
Oh yeah.
I
mean, because almost no one has this type of muscle memory when it comes to like their thumb.
The trackball sensitivity high enough to get good direction control, my precision aiming became way too twitchy and jerky.
Yeah.
I lowered the sensitivity to get better precision, then my direction changes were way too slow. Fortunately, I'd already been using an open source software called RawXL for the controller.
Yeah.
RawXL lets me adjust the input curves for mouse aiming. This makes it so I can have a stable and precise crosshair while still being able to do quick turns with the trackball.
Look at RawXL staying relevant. So essentially with RawXL, if you move, like I would guess if you were to move the trackball like really rapidly, you'll get like a long quick flick, whereas if you move the trackball like slowly, you'll get like a lower sensitivity, like something where like the reticle isn't going to go as far. So you could do like a fast, and it's all dependent upon the velocity that you're moving the trackball.
Once I had my RawXL curves dialed in, it really opened up the controller, and it started feeling super comfortable and intuitive to use.
Nice.
I logged my data doing 20 or so test sessions, pulled in the top 10 scores, and sorted them from worst to best. None of this is particularly great from a data science point of view, but it's sciencey enough for what I'm going for here.
Yeah.
In spread aiming, the custom controller top 10 scores averaged about 85% of my mouse performance. My standard gamepad average score came in at only 61% of my mouse average. That difference was pretty sizable, but it was really amplified when I switched over to my fast cluster target training. This exercise requires really quick twitch aiming, rapidly switching between targets.
Yep.
My standard gamepad performance really fell off a cliff on this. bottoming out at only 37% of my mouse average.
Oh yeah, this thing is gonna look at this thing. Okay, so on the spread ones, like the controller is just coming in dead last on all of this stuff. But like, dude, his custom one is staying like on par with his mouse one. It's like almost, they're not like overlapping, but it's there.
The custom controller stayed constant here at around 84% of my mouse performance.
Mm-hmm.
In my final testing series, I had to maintain tracking on a moving target. In the performance numbers, the standard gamepad came in at a much more respectable 76%.
Oh look, it even got a little bit better on the last ones.
Average against the mouse and keyboard. But I was generally shocked that I managed to put in a 93% comparable score with the custom controller. I feel like with the analog stick for movement, I was more accurately able to match the motion of the target, almost turning it into a stationary aiming exercise. This gave me an advantage using both the custom and stock controllers, ramping up their scores compared to using the keyboard for movement. So what does all this mean? Well, I've documented that I'm pretty bad at FPSs with a standard gamepad for sure. The custom controller was super interesting though. I have who knows how many hundreds of hours playing games with normal gamepads and mouse keyboard combos. I have probably 4 hours total playtime with the custom controller at this point. And despite that, I was able to put up competitive numbers with it, which is kind of crazy. There are also moments with the controller where I would just sort of click into place. I would look at something on the screen and just be able to hit it. Sort of like when you're learning a new sport or musical instrument. There are these moments where you can stop thinking about doing it and just do it.
Yeah, he was like up here, he was probably like cold. And then the more he played, the warmer he got and the more like mind muscle connection-y he got. And like it started to like crest over that. Okay, he's getting it now.
I don't feel like I've hit my skill ceiling with the new controller yet, so it's going to be exciting to see how far I can push it forward. The thing that really struck me about this project is that good ideas are buried in the details. There have been a bunch of attempts to make trackball controllers over the past 30 years, but they were all abandoned for one reason or another. I think what really made my design work was finding the right ergonomics and aiming software with the trackball. Without hitting on those things, the performance would have been much worse and the new design just wouldn't have been fun to use. Turns out it's all about those details.
Yeah.
The other bigger question I have about something like this is where it would fit into the market as a product.
Anywhere where there's an FPS or a shooting game, essentially. But, okay, so here's a question. If you need raw Excel, so essentially your target market would be like what? People that play on PC but play FPSs with a controller. Honestly, this is like, you know how like the Nintendo brand is like a transition thing in terms of like getting like regular people that don't play video games into playing video games. It's like you probably show them like a Nintendo game because it's like lighthearted, it's family friendly, it looks good. And it's like, oh yeah, before you throw them into like the hardcore like PlayStation, Xbox, PC type of games, you know. I think this controller that this person made is like a good transition from someone that's going from console and they want to go into PC, but they don't want to use a mouse still. They want to use a controller still, but they want the functionality of a mouse. So they get your controller, so the performance is similar. That could actually be like really good.
For consoles, you need industry adoption for something like this to work.
Yeah.
That's where I feel like non-conventional controllers would struggle right now.
Yeah.
Game developers and console manufacturers can balance crossplay between mouse and controller players because those two isolated control types have been perfected over decades.
I mean, I don't really think they're perfected, but I mean,
something like this into the mix and all that balancing and playtesting gets messed up.
Yeah.
That being said, the industry is changing. Those lines between predefined input schemes are going to continue to blur and there's no way of stopping it.
Bro, could this be the controller where you have to turn off aim assist? Because if you leave aim assist on, I guarantee you it's not going to feel good. Because let's say you play Apex or something and you play like 4-3 linear. The moment you find your target your sensitivity is going to slow down. And when your sense is slowed down, that means you have to move your thumb in the trackball more to move the reticle on screen like more precisely. So you're going to be like whipping your shit around. Your reticle is going to find a target, and then your sensitivity is going to slow. And I don't know how well that would translate. Maybe not. This could be the controller to make you turn off like aim assist to preserve that mouse and keyboard feel.
I do know that when I cast games from my PC to my living room TV, this controller becomes amazing. PC casting setups are still kind of a fringe thing today, but it's going to be more and more common in the future. And it's always nice when you get those little glimpses of the future. Thanks for watching, and see you next time.
Bro, this is so cool. Bro, this controller, I want to see this dude succeed. Oh my god, I'm a fan. And then look at the top comment. The mouse versus stick debaters keep ignoring the enlightened gyro aimers. Yeah, you know, gyro aim is a thing still with the controller. You know, you move the thing up and down, and it corresponds with the reticle position on screen. But you need flick stick to go along with the gyro aim in order to have like a what do you call it? Like an M&K feel. Having a trackball accessible on the back of the controller is nothing short of fucking brilliant. Bro, that is so cool. Because he could have easily just did the trackball and it's only on like it's only on the top. But he's like, no, I want to be able to manipulate this thing from the top and bottom for like more precision. Bro, this is so cool. I want this dude to succeed. I hope a lot of people see the value in this. This is so cool. But yeah, that's pretty much it for me. And I'm a fan, and I want to see some more of what happens to this thing. Maybe we get like a V2 or a V3 of this type of thing. This is so cool. This dude needs to like Shark Tank this. But yeah, that's pretty much it for me. That's all I gotta say. I'll catch you guys on the next one. All right, peace.